Here we have the keyboard interface, the PS2 connector. We've got the clock and data, it's the white and yellow. Clock's been inverted and sent to the shift registers, chained up, so the shift registers shift at the same time. The data coming in is cascaded down from one to the other, so when it falls off the end of one, it jumps into the other one. The counter is driven by the clock's pulses from the keyboard. This is pre-programmed or preloaded with 11, so when it counts down, the borrow out bit is then inverted twice and delayed, and then it triggers the load. So when it's triggers a load, and I put an AND gate on there so that the reset line from the computer and the load trigger are ANDed together. So if one goes low, the counter chip reloads its value, it loads its counter to 11. Then that triggers also triggers a latch. That's that red wire there. That triggers the latch to latch the data that's currently been shifted in, and when it latches it, that's when it triggers the interrupt. So we've got the 8 data lines for the 8 data bits, foregoing the start, stop and parity bits. This is just grabbing the middle 8 bits, and then we have the ability to add, I don't have a Wi-Fi at the minute, but we can add a line that leaves this and then tells the CPU this line goes low, triggering an interrupt. That can be ANDed with lots of other triggers to trigger an IRQ. So that's the IRQ. This is the enable line that's been tied together for the shift register. So that's effectively the chip select line. That's the interrupt line. That's the reset line. And these are the 8 data bits. So in theory, this is all working at the minute. I've also got AND gates on my main project, which I can reuse, so that's not a problem. I mean, AND gates, these are the open collector, so I've had to put a resistor on there to pull it up to 4.8 volts. So it's a definite one. So yeah, it's shifting in, and the output can be enabled or disabled, and it can trigger an interrupt for the CPU, and it resets on power up, and when you press the reset button, the counter is preloaded with 11 again. So it goes back to counting 11 bits. I've heard people have had issues with their PS2 interface losing sync, either dropping a bit or miscounting at some point, and then the actual data is shifted by 1 bit and you get the wrong values. People have had to reset it. I'm not sure of the specifics of their setup, but this should be overcome by a timer circuit that looks at the time between or after the pulse, and then if it's so many milliseconds or whatever, it'll reset the counter. Then worst thing that can happen is you'll desync, but if you don't type anything, it'll resync again, possibly. But I haven't had a desync problem yet since I've delayed the latching lines with 2 inverters. I did tie the shift register and the latch together, but then you get mid-shifted data being latched, which is obviously useless. So yeah, that's the keyboard interface so far. Fingers crossed when we integrate it, we should be able to just connect these up to the VIA, connect the interrupt line, and in fact the chip enable line doesn't have to be disabled now because it's not going to be directly on the bus. So that can be modified or just held low. because I did have the rather daft and naive idea of just connecting it straight onto the data bus and wiring this up to the address decoding logic. But I don't know, it's late and I could do with some sleep, to be honest. But so far so good. You power it on and it does the reset. That's like the default kind of code that we get through the from the keyboard, and that's F, which is 11010 100. Yeah, 11010 and then that's latched from the counters now. So that won't change no matter what we do with the clock pulses. It triggered, it brought this low